We all mic'd up? All right. All right, good morning, everyone. I'm going to demonstrate some simple and effective techniques for getting Meterpreter by using a single line of PowerShell. My name is Matthew Turner. I joined the red team for a financial institution not too long ago. Before that, I have lots of blue team experience. You can see I have a few SAN certifications. I hope to get my OSCP this year, but with all that said, here it is. This is the one line of PowerShell that I'll refer to throughout this entire talk. This is known as the wget of PowerShell. This doesn't touch disk. It avoids antivirus pretty well. And the way we'll leverage it will make use of things commonly found in an enterprise. At the end, we do need a tool from GitHub, and you also need a system with Metasploit, but that's really as tricky as we're going to get. So here's what I can tell you about this one line. IEX stands for invoke expression. New object creates a new .NET or COM object. Net.web client is a class to access a resource over HTTP. Download string is a method that will download whatever's in those parentheses and convert it to a string. Basically, this will download and execute a.ps1 from host X on port P. The end goal is getting this to run on a target system. I'll go over what you'll need, how to set this up, getting it to run using a teensy, tricking users with a malicious shortcut, creating a macro-enabled spreadsheet, also finding misconfigured MS SQL servers and having them run it, and finding servers with Java applications that unsafely deserialize user input and getting them to run it. So to start, you're going to need three things: a box that you control with Metasploit on it, a method of hosting files, and knowledge of firewall rules or what ports you can connect on. Once those things are taken care of, you'll need to create a malicious PS1, set up a handler, host the PS1, and then get a target to download and execute it. So to create a malicious PS1, I use MSF Venom, and I'm just going to walk through the options. -P is for payload. In this case, we're using Windows Meterpreter, reverse TCP. Your listening host will be the IP address of the system with your handler. The listening port will be the port that your handler is listening on. The format will be PowerShell command, and the output is a.ps1, but you can name it whatever you want. Before you move on, you do need to edit the PS1. The very first thing that shows up in that file is %comspec%. You need to replace that with cmd.exe, otherwise this isn't going to work. So now that we have our malicious PS1, we can set up a handler. So to do that, you just start MSF console, switch to a workspace, which is optional. You'll use exploit multi-handler. You'll set your listening host to the same IP address as what you use in MSF Venom. Same with listening port, same with payload. You can just type exploit. Exploit-j is just to run it as a job, meaning that your sessions will just connect in the background, and you won't automatically just switch to it. So with the PS1 file there and the handler running, all you need to do now is host it. So here are three different ways to do it. There's actually a newer version of the Python command, but for like 3 dot something, but this still works for me. The Python one is easy to memorize, so that's the one I tend to use, but you can also use Ruby or start up Apache and just copy the files of our www.html. You want to watch your port use. So in the one-liner, there is that port that you specified. That's the port that you're going to use because this is the port it'll connect on to download the malicious PS1. So now that's all that's left is just to bring up a run line and type in the one-liner and hit OK. But typing this out really sucks. If you ask me to do it, I'll probably mess it up. So I like to use the teensy. It's been around for more than a few years, and if you haven't heard of it, it's kind of like a magic wand for computers. It's basically a programmable keyboard and mouse. Anything you can think to do with a keyboard and mouse, you can effectively write this thing to do.
Here, try this.
Okay, so does this work? All right. So you could do things with this like move your cursor a pixel every 5 minutes to prevent a computer from going to sleep, or you can solder on light sensing circuits to execute code a certain amount of time after it detects light. So really, the sky's the limit with this thing. The rubber ducky is similar. It's a little more expensive. I bought these teensies years ago, so this is my preferred method. So Dave Kennedy actually demoed one of these for us at Central Ohio ISSA meeting back in like 2012. That's when I bought it, and he demoed it using a W script payload that's currently in set. And it's really cool because it demonstrates everything that the teensy can do. It will start a command prompt, echo out a VBS script, execute it, which will download a malicious payload and execute that, and then it will clean up after itself. However, when I tried to use it, like later that week when I got it, it was broken and it just kind of spit out a bunch of gibberish. So it turned out there was a function in there to encode what you're typing to work with international keyboards, and that was breaking it. So I ended up removing that, and that fixed the W script. But if you wanted to get in on this, all you have to do is go to PJRC. You could buy one of the 3.x versions for about $20. On their website, they have pretty solid instructions for installing the software. You need a specific version of Arduino, and that will compile your code. You'll also need the teensy loader. This will communicate with the teensy when the bootloader is running. And finally, you need a copy of HeartRules that they provide. And this will tell your system that you're allowed to write to it. And the code that you'll write to it, and the code that we're about to go over can be found on my GitHub right here. And here's the code. So as I just said, this started out with sets W script code for the teensy. Basically, this code will wait about 10 seconds for the computer to recognize that a new keyboard has been plugged in. It'll then hit like Windows R or Super R. It'll type in the one-liner and hit enter. And that's all that needs to happen. It runs once, so that's why void loop is empty. It's not continually looping. Once you plug it in, it'll just run. You can press a button on the teensy and it will run again, but that's not usually necessary. So here's a quick fail story. As I said, I started with the W script and I ended up like just chopping stuff out. And I ended up looking again just to see what else was available. And then I saw this in set, and it's pretty much the same exact code. The PowerShell that's being used is just a little bit different, but I think mine works better. All right, so as soon as this video starts, what we're looking at is the victim's computer. So we plug in the teensy, and this is what the victim would see if they were there. And in the back left, you see I'm hosting the file and that the victim downloaded it. And in the back right, you see I have a Meterpreter session. And the front's just explaining what was typed. So that was about 17 seconds. So once you get up and walk away from your computer to use a restroom or whatever, that's about as long as it takes for someone to do this. All right, so that's the teensy. It's pretty simple. It's effective. Like I said, it works like within 30 seconds, and it's pretty fun to walk around the office carrying one of these things. The cons, single target at a time. They got to be away from the keyboard, and to mitigate, you can implement some form of strict USB controls. I think you'll have better luck with your users just for training. Let them know not to plug in found USB devices and, lock your computer. You should also enforce lockout timeouts if you're not doing so already with like group policy. Fun with shortcuts will be a pretty quick one because this is not anything difficult. So all you really need to do is create a shortcut, set your location to the one-liner, and then name it something interesting to encourage clicks. That's going to have the PowerShell logo, so you're going to want to change it back to the folder icon that we're all used to seeing. And you can scatter these around on like network shares, but you'll probably have better success with this if you're using it in some form of phishing or like USB leave behinds. In my experience, the click rate just wasn't there to justify the effort because you're going to have to go back and clean all these up. So that's what a shortcut looks like. I'm sure you all are familiar with that. And here's me creating a shortcut. These are elite hacks. Use them carefully. Oh my God, so elite. All right, so there's a shortcut. And if you double click on it, you see that, well, that doesn't look right. And in the back, you see, downloaded it. And there's my Meterpreter session. So that's pretty handy. The pros of using shortcuts, it's simple and effective. You're casting a wider net. The cons, you're creating a bunch of shortcuts and linking them around. To mitigate this, you can limit file permissions. You probably shouldn't have a world writable network share for everybody in your enterprise. You want to train your users. If they see something suspicious, they ought to report it. And someone should probably review files on network shares anyway, especially when they have a lot of access, just to make sure stuff like this isn't floating around. Fun with macros. All right, so I went to ShmooCon this year, and I was really inspired to create a macro-enabled document to run the one-liner because I just never done it before. During one of the talks, the presenter said they should rename the Enable Macros button to YOLO. And that's when it occurred to me. I was like, I've never actually had to do that or need to use it. So on the train ride back, I decided just to give it a hand. So I just went at it and made a simple spreadsheet, made it look like it would disclose salary information if you enabled macros, and that was that. So here's some tips when you're using macros. You do want to encourage clicks, so dress up the spreadsheet a little bit. When you're writing your macro, the double quotes inside the one-liner need to be escaped with double quotes, but the better option is to just base 64 encode the one-liner. That way it's just not obvious to whatever user is just looking at it. All right, so here's me creating a macro-enabled spreadsheet. Yeah. The back right, I'm hosting the file. The back left, I have my handler running. This is what the user would see when they enable macros. Not a whole lot. So in the back, you see the victim just downloaded it, and you see my Meterpreter session starting. So macros are simple and effective, and they have been since 1995. The cons, in my opinion, are still sort of easy to catch, and again, you're creating files and leaving them around. But you can defend against it just by disabling macros with group policy, blocking them at your Exchange servers, and training your users not to hit that button. So now let's get in a little bit more into Metasploit. With this auxiliary module, we'll scan targets. We'll scan a targets file for MS SQL servers that have an SA account enabled with either no password or the username is the same as the password. This isn't that common, but any organization can lose track of servers, or maybe someone that doesn't know what they're doing is just trying to get something up and running. And as a pen tester, it's just worth checking out because it's so simple to do. So to do it, you just start MSF console, switch your workspace, use auxiliary scanner, MS SQL login, set your rhost file to your list of targets. Chances are you may have a few hundred, if not 1,000 of these. Set blank passwords to true, set users passes true, increase your threads if you're worried about performance, spool your output so you have something to look at to see what worked. And all you have to do is run it. So assuming you find something that is vulnerable to this, you can now use the auxiliary admin MS SQL exec. Set your rhost IP to whatever came back as being vulnerable. If it shows that it has a password, then set your password to that. And then at this point, you really have no other choice but to use the base 64 encoded version of the one-liner. So set your command to that. And here's a tip for doing that. You can just paste the one-liner into a file, cat it, and use icon V from UTF-8 to UTF-16 little endian, and pipe that to base 64, and -W is to turn wrapping off. That's a 0. All right. I think the encoding might be a little messed up on this one, but only for a little bit. Yeah. This will get fixed in just a second. So I'm in MSF console, switching my workspace. In the bottom left, I'm hosting the file. In the bottom right, I have a handler running. The top right is where I'll be doing the base 64 encoding. So again, setting users pass to true, blank passwords to true. I'm sorry, at this point I'm actually doing scanning. So you can see I just found something that's vulnerable, workstation SA. That means the SA account has the password of SA. So now switching over to MS-SQL exec, setting the password to SA. All right, so again, you just take your one-liner in a file. Cat that to IConv for the UTF conversion. So there's a base64 output. You just copy that and paste that into your command. Yep. All right, everything looks good. So now we exploit. If you do this the first time, you might get a warning that XP command shell isn't enabled. If you just hit yes, it works just as well, and usually you don't see it again. All right, so you see in the bottom left, it did download it. Bottom right, I now have a Meterpreter session on that SQL server. So again, this is very simple and effective. The cons, you need to find something like this that actually exists, which should be pretty rare, but again, it still still worth looking into. To mitigate this, use complex passwords and disable the SA login. There might be more. I don't really know a ton about MS-SQL, but this seems to be a good place to start. Okay, so this is the good stuff. This could easily be its own topic. Anyway, this was first announced over a year ago, and then in the late fall, it had moderate visibility in NetSec. And deserialization vulnerabilities have been around for years, and there are Metasploit modules for some, which are great. But this latest tool that I've been using by Frohoff called WhySoSerial, it really shines a light on these vulnerabilities again. And this is even evident because PayPal just dished out like $10,000 this year for 2 testers or bug bounty participants finding the same vulnerability. So these do exist. I think they will exist for a while. So it's worth loading this tool and scanning your network. For more information on it, you can go to Frohoff's GitHub and check out his wiki. This is actually straight from his wiki. So the way it works, the main driver program takes user-specified commands, wraps them in a user-specified gadget chain, serializes these objects to standard out. The application unsafely deserializes this data, and then the command will execute on the application host. So basically, WhySoSerial with the one-liner is good times. So to install it, you just do a git clone, cd to WhySoSerial source main Java, because the way that you use the command, you actually have to like browse to a certain class. It's kind of funky. And do a wget of his latest jar. So to find, there are default ports that tend to be vulnerable, 1099 being one of them. It's worth looking into other ports because there are a ton of apps that will listen on different ports that are vulnerable. Now it gets a little clunky because the tool is still sort of young. So you have to use for loop, or at least you should use for loops or some sort of Python script to iterate through all of the different payloads available and all the different ports that could be vulnerable. So it may be best to reference vulnerability, report first. So if you ever see anything like JMX, RMI, JBoss, Jenkins, WebSphere, all these things are worth looking into if your vulnerability scanners are reporting them as potentially vulnerable. Here are all the different payload types that you can use. You need to go through every one because not all of them will work, but maybe one might. And here's how I tend to scan. I will just have it ping me, and I'll just start TCP dump, and if I get a response, then I know it's vulnerable. So we can weaponize that just by giving it the one-liner. And use Java CP as class path, the jar file. There's the class path, the WhySoSerial exploit, RMI registry exploit. There are other exploits when you download his GitHub. However, they don't all work. As far as I'm aware, only RMI registry exploit works because it's actually compiled into that jar. The rest you would need to recompile, and they seem to be more for web apps anyway, which is also worth looking into. I just haven't gotten there yet. So here it is in action. I just used WhySoSerial to execute the one-liner. In the back right, I'm hosting the file. And in the front, I have my handler. And there's my Meterpreter session. So this is simple-ish. I mean, you do need to install a third-party tool, and you got to know for loops or some Python. But it's still very effective. I've been having a very high success rate using this. It's also a very low-key vuln. Not a lot of people seem to know about it or exploiting it. So your blue team may not alert on this. But the cons, again, you need to load WhySoSerial. The scanning itself could get you caught if that's a worry of yours. And executing this can actually get you caught if your blue team has written the correct snort rules. It's kind of hard to do. It may not catch them all, but it's a good place to start because you're effectively exploiting intended functionality. So it's difficult to write a rule for that, but it's not impossible. Also, if none of these work, it's also worth just doing a scan with Java RMI server that's built into Metasploit. It's from 2011, but there's a lot of things just hanging around from around then that haven't been updated. So that's also worth scanning your network for. To mitigate this, you patch and update libraries, and again, create snort rules. So that about does it for me. If you want, you can hit me up on Twitter. I want to give a big thanks to SQL7 for all his help, to Frohoff for WhySoSerial, to Microsoft for PowerShell, and that does it.